You tap your screen, a video starts to play. Feels instantaneous, right? Like it's just magic pulled out of some invisible cloud. But what if I told you that in that split second, you're actually commanding a tiny particle of light to race across the ocean floor and back? Today, we're going to pull back the curtain on the incredible physical reality of the internet.
Okay, so first things first, let's just get this out of the way right now. The internet is not a cloud. It's not some fluffy, ethereal mist of data just floating around above our heads. That's just, well, it's a marketing term.
The reality is so much more impressive. The internet is a tangible thing. It's this sprawling, planet-wide labyrinth of glass and steel and copper. It is, quite literally, the single largest and most complicated machine ever built by humankind.
That video you just clicked on, the whole globe-spanning relay race to go get it and bring it all the way back to you, happens in about this much time, 50 milliseconds. That's less than half the time it takes you to blink. So let's just freeze time right there and follow the journey of that single request.
Our story starts, of course, right inside your phone. Every single time you do anything online, send a message, load a web page, you create a tiny little digital messenger. And we're going to follow just one of these messengers on its absolutely epic journey.
So let's give our little guy a name. We'll call him Dash. He's basically a digital courier, and his whole job, his entire reason for existing, is to carry one simple message. Hey, I want to watch this video. But right now, he's trapped inside a phone, and his destination is thousands and thousands of miles away.
Okay, so first, bam, Dash blasts out of your phone on a Wi-Fi signal. He hits your router, which acts like a local postmaster, swapping his private home address for a public IP address the rest of the world can actually read. Next up, the modem acts as a translator, converting him from the digital language of computers into analog signals that can travel over physical wires. And with that, he zips out of your house and arrives at your internet service provider, the on-ramp to the global information superhighway.
So now Dash is on the open internet, and he is facing two absolutely massive challenges. First, he has to figure out where in the world he's actually going. And second, he has to physically get there at, well, pretty much the speed of light.
And this is his first big problem. See, Dash's instructions say go to youtube.com, but computers don't understand names. They only speak in numbers, these long, specific IP addresses. So how does he find the right coordinates?
He uses the internet's phone book, which is called the Domain Name System, or DNS. And it's this crazy split-second detective hunt. First, a request is fired off to a root server, which says, I don't know the exact address, but I see it ends in .com, so go ask them. The .com server says, nope, not me, but I know who manages YouTube, go ask them. And finally, YouTube's own server provides the exact IP address. This entire global conversation back and forth takes about 12 milliseconds. It's insane. All right, now that Dash has his coordinates, another system kicks in called Border Gateway Protocol, or BGP. You can think of it as the live traffic map for the entire internet. It's like Waze for data. It sees a traffic jam on a cable in New York or a router that just went offline in London, and it instantly calculates the absolute fastest, most efficient path for Dash to take in that exact moment.
With the route now plotted, Dash is converted into a photon, a literal particle of light, and he's shot into a fiber optic cable. He is now traveling at this ridiculous speed, about 2/3 the speed of light in a vacuum, bouncing his way across the country inside a strand of glass that is no thicker than a human hair.
So with his route planned out, Dash reaches the coast and plunges straight into the Pacific Ocean. Yeah, forget satellites. Over 99% of all international data travels through these physical cables, most of them about the size of a garden hose, just laid right across the dark, freezing seabed. And to keep that light signal strong, optical amplifiers give it a boost every 50 miles or so, helping fire Dash across thousands of miles of deep, dark ocean.
After a 5,000-mile journey across the ocean floor, Dash finally emerges on the shores of Japan and races inland. He's about to arrive at the actual physical building where the cloud lives.
And this is it. A massive, windowless, concrete fortress, just humming with the roar of air conditioners the size of trucks. It is deafeningly loud, it is freezing cold, and it is a metropolis of servers, racks and racks of them, all blinking and processing requests from every corner of the globe. Dash navigates the aisles and at last delivers his message to the correct server.
So, Dash's tiny little request has been delivered, mission accomplished for him. But now we have a much bigger problem. The video file we want is millions of times larger than Dash was. You can't just send that back in one piece. That would be like trying to mail an entire house through the postal service.
The solution to this problem is, and I'm not exaggerating, one of the most brilliant pieces of engineering in all of modern history. Instead of sending one big clunky thing, the server in Japan creates an entire army of messengers to carry the video home.
This is all done using something called the Transmission Control Protocol, or TCP. And it basically acts like a digital butcher. It takes that massive video file and just violently chops it up into thousands of tiny bite-sized packets. And crucially, it numbers every single one of them. Your packet number 1, your 2, your 3, and so on. Now, for a pretty standard 50 megabyte HD video, we're talking about roughly 35,000 individual packets. An army of 35,000 digital messengers, each one stamped with your IP address, all ready to be blasted back across the globe.
And here is where it gets truly mind-bending. This is the decentralized nature of the internet in action. These 35,000 packets, they don't fly in formation. BGP, that live GPS, it charts an individual course for every single one. One might zip through Hawaii, another might get routed through Australia, a third might shoot directly back to California. They are all racing home along billions of possible paths.
So because they all take these different routes, they arrive at your phone completely out of order. 14,000 might show up before number 3. And sometimes, a packet just gets lost. A router gets busy, a connection flickers, and poof, it's just gone. So, what happens then?
This is where the magic of TCP comes back in. The TCP system on your phone is basically doing a head count. It sees it has 34,999 packets and realizes, hey, wait a minute, I'm missing packet number 14,203. It immediately fires a tiny message all the way back to Japan saying, resend that one. The server duplicates the missing packet and fires it right back across the ocean.
The missing piece arrives, it snaps into place, and the file is finally complete. The packets are all reassembled in perfect numerical order. And the total time for that entire round trip, the request, the detective hunt, the ocean crossing, chopping up the file, that army of 35,000 packets all racing home across different continents, and the final error check was 50 milliseconds. I mean, it is just an astonishing feat. It's not magic, it's not a cloud, it is a physical nervous system for our planet, a true triumph of engineering that we get to use every single day with just the tap of a finger. So, the next time you're waiting that extra half second for a video to load and you see that little buffering wheel, just think of the incredible, chaotic, globe-spanning journey that's happening behind the scenes. Your little router is coordinating an actual miracle. Cut it some slack.
Please like and subscribe.